Welcome friends to my channel. Now on yesterday's lecture I have mentioned about the concept of moment of inertia. Okay, and I also told about the rotational kinetic energy, angular momentum and torque, and the physical significance of moment of inertia. Now in this today's lecture I shall going to discuss few other issues, okay, related to moment of inertia. Okay, now previously we have write this expression that previously we have seen this expression that angular momentum L this is equals to I omega. Okay, and by differentiating this expression with respect to t, we also get another relation, that is I omega dt. Okay, and rate of change of angular momentum means torque, and rate of change of angular velocity means angular acceleration. And we will find that for unit angular acceleration, the torque is numerically equal to the moment of inertia. Okay, that we have found. So let us discuss another issue in today's lecture. Okay, we discuss about the two important theorems. The first theorem is perpendicular axis theorem. Perpendicular axis theorem. We are going to discuss this theorem first, because later we have to find out the moment of inertia of different geometrical objects, and before doing that we must have to know two theorems: what is perpendicular axis theorem and what is parallel axis theorem. So let us understand this. So let us take a plane laminar body. Okay, let us take the example of a say plane laminar body. Okay, let us take the example of a plane laminar body. Okay, okay, suppose this is z axis, this is y axis, and this is x axis. Okay, so 3D, not 3D, that is simply choose a plane laminar body, plane laminar body. Okay, we choose a plane laminar body. Okay, so there are three axes, x axis and y axis are in this plane, and z axis is perpendicular to the plane. Okay, we choose the z axis perpendicular to the plane, and x and y axis lies in this plane, that is the plane of the lamina. Okay, now take a point, just p. Okay, okay, so this is simply x and this is simply y. So if you consider a particular particle of mass m of the entire body, okay, the entire body is made up of large number of small particles, that we all know that a rigid body is composed of large number of small particles, where the distance between any two consecutive particles are fixed. Okay, so in this case we assume that the body is made up of large number of particles and take such a particle of mass m. So at first, what will be the moment of inertia of the particle of mass m about x-axis? Okay, let us take. So moment of inertia of mass m about x-axis, that is what, mass into the perpendicular distance, that is the distance of the point P along x-axis is this, that means y. So mass into y square. Okay, okay, so this is the moment of inertia of the mass m about x-axis. Okay, So what will be the moment of inertia of the entire body about x-axis? So similarly, moment of inertia of the entire body. Okay. So the moment of inertia of the entire body about x-axis. This is simply, if I denote it Ix, just we take sum of this, because this body is composed of large number of particles. Okay. First, we find the moment of inertia of the particle of mass m about x-axis, and taking summation of that, we get the moment of inertia of the entire body about x-axis. Fine. Now, what will be the moment of inertia of the particle of mass m along y-axis? That is similar m into x square. Okay. So, moment of inertia of the particle along y-axis. This is simply m into x square. Fine. Now by taking summation of this, we get the moment of inertia of the entire body about y-axis. Okay. So what will be the expression? So let's write it. Okay. So moment of inertia of the entire body about y-axis, that we can write as Iy. Okay. That we can write as Iy. So this is simply summation of m into x square. Okay. So we will get this Iy, this is equals to summation of mx square, and Ix, this is equal to sum over of my square. Now if I add these two, what we get? If I add these two expressions, that is Ix plus Iy, we get summation over m into x square plus y square. Now what is x square plus y square? That is simply this. If we take it r, this is r. Okay. X square plus y square means r square, and what is the r? That is distance of the observation point P from z axis. That means simply we can write it Iz. So what we see, that the moment of inertia about an axis perpendicular to the plane of the lamina is equal to the sum of the moment of inertias along x and y axis. Okay. These two axes x and y lie in the plane of the lamina, and by using perpendicular axis theorem, we find that sum of moment of inertias along these two axes is exactly equal to the moment of inertia about an axis that is perpendicular to the plane of the lamina. So this proves the theorem. Okay, so this proves perpendicular axis theorem. Okay, so this is very simple. Okay. Fine. So this is perpendicular axis theorem. Okay. Now let us move to the second theorem, that is parallel axis theorem. Okay. So our next task is to find out, that is another theorem, that is parallel axis theorem. Fine. one is perpendicular, that has been done. And again, for simplicity, here we assume a plain laminar body. Okay, these theorems can also be proved for a 3D body, but that is little bit of complex, so that's why for simplicity I am taking the example of plain laminar body, which is useful to you. So just take a body, say rigid body, choose an axis passing through this body, okay, and take another axis parallel to this axis. Okay, so give this axis a name, say AB, and this axis a name, that is CD. Okay, we consider a plain laminar body and take an axis CD such that this axis passing through the center of gravity. Okay, and we also take another axis parallel to this axis CD. So we assume that the distance between two axes is say h. Say h. Okay. Okay. And you take a particle of mass m, say at a distance say x from CD axis. Okay. The body is composed of large number of particles, so you take a particle of mass m at a distance x from the CD axis. That means, just notice this, the object of mass m is at a distance x from CD axis, and that at a distance x plus h from the AB axis. It is clear from the picture. So what will be the moment of inertia of the particle of mass m about AB axis? Okay, so moment of inertia of the particle of mass m about AB axis. Okay, moment of inertia of the particle of mass m about AB axis. Okay, so this is simply m into, that is what is with respect to AB, that means we have to consider the distance between AB and mass m, that is this is h and this is x, so x plus h whole square. Fine. So what will be the moment of inertia of the entire lamina about AB axis? Simply you take the sum. So if you consider the moment of inertia about of the entire body about the axis AB as I, okay, so this is simply sum of, this is m and this is x plus h whole square. Okay, where we denote I is the moment of inertia of the entire lamina about the axis AB. So just simplify this. So this is sum, this is x square plus h square plus 2hx. Okay, so this is sum over of mx square plus sum over of mh square. And what is this? This term h is constant, we can write in this way. Okay, now what is summation over mx square? Summation mx square, that means summation is here, that means this term represents the moment of inertia of the entire body about the axis CD. So just give it a name, that this is AB. Okay, so this term represents the CD, that is ICD. Okay, and summation of m, that means the entire mass m into h square, and this term will become 0. Why? Because here we consider this as the center of gravity or the center of mass. Okay, so if you just take the particle at this point, then x is 0. That means the sum of the moments of weights of all particles about this is always 0, because when you are choosing the particle at any point that lie in the axis, the x is always 0. Therefore for the entire body this term cancels. That means in general you can say the entire body is balanced about the center of gravity. the entire body is balanced about the center of gravity. That's why the sum of the moments of weights is 0. So this term vanishes, so you get the result. Okay, so the ultimate result is IAB, this is equal to ICD plus mh square. That means moment of inertia of the body about this axis, this equals to moment of inertia the body about that axis plus mass into the, the square of the distance between the axis. So this is called parallel axis theorem, because here we choose the axis parallelly and previously we choose the axis perpendicularly. So these are the two most important theorems that we should learn before starting or before calculating the moment of inertias of different geometrical objects. Okay, so this is up to today. If you don't subscribe my channel, then kindly subscribe it to get latest videos, and the link of this video will be given in the description box. Okay, and if you have any question, then just ask it or write it in comment section. Okay, thank you.